Welcome to this video lecture on scientific research in information systems. This video lecture is about research design. In particular, we will be covering scientific terminology and clarify a few terms and labels that scientists use all the time when they discuss research design. We will cover the realms of reality, theory, and measurement, and clarify the differences between phenomena, concepts, and constructs, as well as the differences between propositions and hypotheses. The main reading for this video lecture is Chapter 2 from the book Scientific Research in Information Systems, a Beginner's Guide in its second edition from 2021. In particular, Chapter 2, Information Systems Research is Assigned. This book is available as a hard copy, soft copy, audiobook, ebook, as well as electronic PDFs, and a link to the chapter is provided below. It is usually available via library provision through the academic institution that you're at. So let's cover research terminology. This is a diagram from the book that tries to clarify how scientists talk about research that they're doing. The starting point is, of course, some phenomena in the real world. Now, these phenomena, they could be very tangible, they could be physical, they could be real objects in the world. And if they're naturally occurring objects, then we would call that the natural science. A naturally occurring object might be a tree, an animal, a living being, waves, wind, anything like this. So these phenomena, and a phenomena might be a certain behavior that such a naturally occurring thing does, or anything else. In the social sciences, we usually look at a social phenomenon. A social phenomenon is a socially constructed phenomenon that is not necessarily naturally occurring. It's not necessarily tangible, so it doesn't necessarily have geospatial attributes such as weight, location, mass, height, and stuff like that. So, for example, when we think of an organization is a social phenomenon. It's a socially constructed term. What we mean with this is usually something like, the place where people work, or a place where people meet to achieve a common goal, things like this. Yeah. So you can think of an organization as a building, of course, but as we all know, some organizations, they spread across buildings. Virtual organizations don't even have a building. So this could be a social phenomenon. There's still some real world phenomena. There are organizations in this world. There are families in this world. There is love in this world. There is religion in this world, and so forth. These could be social phenomena. Finally, it could be an artificial phenomena. An artificial phenomena could be is a thing that is not socially constructed necessarily, so it's not a latent phenomena, and it's also not a naturally occurring phenomena. It could be a man-made phenomena, like a bridge, a car, or, of course, digital technologies, computing devices. All of these are not naturally occurring, but of course, they're very tangible and real. A computing device like a smartphone is a thing we can touch and grasp, and it's something that people have built. In information systems research, we're usually interested in some phenomena that concerns both social phenomena, people, groups, collectives, organizations, friends, societies, anything like that, together with some artificial phenomena, namely digital information and communication technology. This could be computers, this could be smartphones, but this could also be electronically occurring things like online social media or anything like this. All of these are phenomena that actually occur in the real world. They could be perceived, they could be latent, they could be real. So this is what we call the realm of reality. And that's usually what we're interested in. It's usually also our starting point in research, phenomena in the real world. Typically, we don't look at all the phenomena. We look at particular kinds of phenomena. And as I said, in information systems research, these tend to be both social and technical, so social phenomena as well as artificial phenomena that are man-made and not naturally occurring. If you're a physicist, you're usually interested in natural phenomena, such as, planetary objects, or even things that we can't really grasp and see, but this still describes the behavior of naturally occurring objects. Think of gravity, for example, or magnetic light waves. What we usually do when we discuss and talk and think about these things is that we move from the reality into the realm of theory. What does it mean? That means we engage in a process that is called conceptualization, a process of interpretation and abstraction from an actually occurring instance of a phenomena into a more abstract concept that describes this phenomena. So, for example, I could think about ChatGPT. That's an actual tool, a product that a company has provided and that you can, use in the real world by going to a web page and opening a browser and so forth. And that is a phenomenon, that is an instance of a class of technology that we label generative AI, generative artificial intelligence. Generative artificial intelligence is not a thing. It's not an instance. It's a class of things. It's a class of a set of technologies, of actual programs, software programs usually, that we bundle under this concept. So generative artificial intelligence is a concept, an abstract label that we use to describe a particular kind of technology that share a couple of characteristics, and of course are different in their characteristics from other types of technologies. Yeah. So in this particular example, a generative artificial intelligence is different from other type of artificial intelligence that is not generative, for example. And of course, it's different from other type of technology that is not intelligent. Okay. So here we talk about the realm of theory. In the realm of theory, basically have two key terms, which are concepts, which are the labels that we use to describe kinds of phenomena, classes of phenomena that share certain characteristics. And we link different concepts together with a so-called proposition. So a statement about how two or more concepts relate to one another. So for example, we could say something like, ChatGPT, a real phenomena in the real world, is an instance of generative AI, a concept, and that relates to another concept, namely, let's say, our problem-solving ability. That's another concept. That's not a real thing. This is just a term that we use to describe people's skills in solving a particular type of task, namely a problem-solving task. And an instance, an actual phenomenon, an instance of such a problem-solving task could be to solve a math equation. Yeah, a particular math equation, such as what is the integral under a certain function or something like this. This could be a real phenomena, and that's an instance of a problem-solving task, and people have more or less abilities to solve them. So now that we have these concepts, problem-solving ability on the right, if you want, and generative AI on the left, we could now link them with a proposition, with a suggested association. And that could be something like generative AI improves people's ability to solve problems. And that would be what we call a proposition, a theory, if you want, an expectation or an assertion about how these concepts might be related. We're still in the realm of theory. These are basically disconnected from reality. So we can make propositions that have no counterpart in the real world. That may not be a good proposition, or it may not be a realistic proposition, but we do this very often. For example, we could have predictive propositions. We could make propositions about how things relate to one another that don't yet exist in the real world. So, for example, we could say, generative AI will make the profession of university professors obsolete. Now, that's not the case at the moment. So this phenomena doesn't occur at the moment in our real world. But one could think about, and one could make the argument that maybe this is a future scenario that could pan out. Now, a third realm that is important to research is then the realm of measurement and evidence. So basically, what we're trying to do is we take our realm of theory, where we delineate or make assertions about how concepts relate to one another, and then we have to go back into the realm of reality to test them. But we don't directly go back to the realm of reality. Instead, we typically go into the realm of what I label measurement and evidence here. What does that mean? That means that for each of the concepts that we've just defined or created, we need to create a so-called construct that serves as an operationalization of that concept. Yeah. So, for example, when I talk about problem-solving ability, I need to find a way of making that measurable. Yeah, a problem-solving ability could range from low to high, but that is very vague and imprecise, of course, right? So if I wanted to do scientific measurement on this, I would need to find a way of defining what is a low problem-solving ability. How would I measure that? through what variable could I operationalize problem-solving ability between different people that allows me to precisely differentiate their skills in solving, let's say, math equations. Yeah. So, for example, a very simple operationalization would be that a math equation could be factually correct or incorrect. So, it could have an operationalization that is something like a binary variable, correct, incorrect. Or, of course, I could have a range of mathematical equations, like a math test that people do, and with, let's say, 100 questions in them, and every question could be false or correct, and then I could simply sum up your test scores, and then I get a score from 0 to 100. That is an operationalization of the ability to solve problems. The nice thing about this way of operationalizing is that it's a more fine-grained and hence more precise way of measuring different levels of ability, because the original operationalization as yes or no or correct, incorrect is binary, right? You're either good at this or not. And of course, most people are more or less good at it. Yeah, so they're not black or white, but they could be good in problem solving to a different extent. So that would be a way of finding variables, measurable entities that really do exist or allow us to make a statement about something that really exists in the real world. And that is a good and appropriate measurement of the concept that we have. So we have to do this for every concept. Yeah. So we find one or more variables as that define the construct that operationalizes our concept. And our proposition has to also be reformulated into what's called a hypothesis. Hypothesis then is a formalized, operationalized expectation, a precise expectation about how one variable relates to another variable. Remember that in my example, I talked about a ChatGPT, generative AI, improves people's ability to solve problems. Well, that is a very generic and in that sense vague proposition. And in my hypothesis, I would have to become more specific. For example, I could say people's use of ChatGPT in minutes. That could be a variable. How much am I using ChatGPT as an instance of a generative AI technology? 1 minute, 2 minutes, 10 minutes, and so forth. Improves my ability to solve problems measured as my test scores in solving math equations, my score from 0 to 100. And I could say my hypothesis could then be that the more time I use ChatGPT will increase my test score in math problem solving. That would be a more precise hypothesis as a statement how two variables, time spent with ChatGPT, relates to another variable. Test score in a math test. And the hypothesis here is that, this goes up. It's a positive association. Now, as this example, you may think that this is a ridiculous example, and it is, right? And you can see here that in the theoretical realm, as well as the realm of measurement and evidence, I'm not saying that any of this is realistic or actually has much to do with the realm of reality. Yeah. So in reality, you could watch someone using ChatGPT and still not be able to, become better at math. Or of course, we could think about that someone uses ChatGPT, but not to improve their math skills and stuff like this, right? So this point here is to say that there are actually distinctions between these three different realms. Yeah? And of course, what we're trying to do is we try to maintain as close a connection as possible, but that's either not always feasible or not always done. So here are the definitions of these examples that I talked about. So with conceptualization, we mean a mental and cognitive process by which we're trying to take fuzzy and imprecise labels and the constituent components and define them in very precise terms. So when we talk in the real world about prejudice or religion or sexual orientation or usefulness or fun or happiness or any of these things, in science, what we would try to do is become very as precise and clear as possible about what these concepts, these labels, these terms mean to us. And that in the social science, including information systems research, is a very important process because many of the phenomena we deal with are very imprecise and ambiguous to begin with. Yeah. So, for example, when we talk often about the usefulness of the technology, but what do we actually mean with usefulness? Useful to what? Useful to whom? How useful? Yeah. Or we talk about satisfaction with technology. What is actually satisfaction? Is that content? Is that delight? Is this surprise? Is this usefulness, perhaps even? Yeah. So in conceptualization, this is a very important process, is we try to get to a level of precision and clarity in our definition that is important, because this way we can be very clear about what it is that we mean and what we're studying, and that allows other people to relate what they think, what they mean, and what they study to our concepts. And this avoids the problem that two people might both study satisfaction, but they mean very, very different things. So, a concept is thus an abstract and general idea inferred or derived from specific instances that we perceive in the real world. They're mental representations that we develop, typically based on experience in the real world, not necessarily though, to give us a vocabulary to reason about the real world phenomena in an abstract, more general sense, and as a means to ascribe characteristics or properties to those phenomena and the relationships that may exist between them. Yeah. So these concepts are labels that we use to describe phenomena that really exist in the world: dogs, clouds, pain, empathy, emotions, usefulness, intelligence, or anything like this. Yeah. Concepts are linked to one another via propositions, not via hypotheses or anything like this. A construct is an operationalized concept. So it's a concept that we defined, but we now attempt to take the abstract meaning of that concept, for example, education, and operationalize it back to something that we can actually measure in the real world. Education is a concept we can define in a way that we probably can talk about it and agree upon it, but I can't measure education. What I can measure, however, is, for example, your scores in high school exams. I can give you a GPA, a grade point average in your bachelor degree, and I can make that comparable, right? So GPA would be a construct to measure a concept such as level of education. Yeah. So a construct is the creation of an operationalization of a concept in a way that we can define it in terms of how we can measure it. It can be unidimensional, multidimensional. So for example, we agree that people and other objects have weight and height and volume, and we have typically one agreed measure to do this. So for example, in Europe, we measure weight in kilogram. Yeah. In other places of the world, you have a different measure for this, but you have one measure. Many of the concepts that we're interested in, especially in social science, because they have several underlying dimensions and multiple characteristics that describe them, we have multidimensional constructs that have several underlying dimensions. So, in other words, several variables through which we measure it. A good example here is intelligence. Intelligence is typically defined as something like the ability of a person to do higher order reasoning and problem solving. Something like this, right? I haven't looked up the actual definition. That's the concept. A typical way of operationalizing it through a construct is the IQ, the intelligence quotient. Yeah, that is a battery of tests, so many, many variables that allow to measure a person's ability to solve a variety of problems that we link to intelligence, such as abstract reasoning, graphical reasoning, word reasoning, mathematical reasoning, geometric reasoning, and so forth, right? It has a lot of tests, about 150, and we construct a score on that, which is, and the average of all human beings is the score of 100, right? And if you have an IQ of 120, it means that you're 20% better in this particular operationalization of intelligence than other people. Yeah. So this is what we've done, and IQ is a very famous operationalization of a multidimensional concept, intelligence. But of course, it's not without criticism. So, for example, the typical IQ test doesn't measure social intelligence or emotional intelligence. So, our like how intelligently we deal with emotions, or how intelligently we behave together with other people. Yeah. Also, it has been criticized that it's a very Western world understanding of intelligence. Yeah. So, for example, it's pretty germane to the way that our languages, so German, French, English, etc. These types of languages operate, but for example, very different from how Chinese or other Asian languages operate. So, in other words, if you do a standard IQ test somewhere in Eastern Asia, people will likely have a lower score, not because they're less intelligent, but because the way that the verbal intelligence tests are constructed contradicts the way that they construct their own language. Yeah, so you see, this gets pretty complicated. Also explain propositions, hypothesis. Propositions link concepts. Hypothesis state the relationship, the operational and measurable relationship between variables that we have as operational relations of a construct. You know? Hypotheses are important because these precisely state a directional or causal relationship between variables that we can actually measure or relate to things in the real world. Yeah, propositions are tentative or conjectured relationship between abstract labels that we have. Yeah. So let me finish this brief lecture with another example. I've talked about intelligence. And one way to think about the relationship of intelligence could be that we see a person, um, you know, think about your professor in a class, and you might think this is a very intelligent person. But now we could think, well, is that an intelligent person or is this a knowledgeable person? Is this a person that is really smart, or is this a person that has read a lot? And if this is a person that has read a lot, is it because he's old, he or she is older than us, so he has had more opportunity to learn knowledge? Or is this really a person that, all things being equal, is really smarter than you? Right? This could be a question that people ponder when they sit in class and listen to a professor who's usually older. Usually has read more, and therefore may come across as more intelligent. Now, this could be a question that we have in the real world. If we were to move from this realm of reality to the realm of theory, we could now think about this phenomenon in more abstract terms. So, for example, we could think that the apparent intelligence of, let's say, a university lecturer could be a function of his literacy, so how much this person has read, and his age. So we could have two concepts on the left hand side, which one of them is age, the other one would be literacy, or like engagement with the literature, or like a label like that. And we could have propositions that increasing age makes people more intelligent, and reading more books makes people more intelligent. These would be propositions that would explain why this person appears more intelligent in class. Now, if we were to test that theory, we would now have to move into the realm of measurement and evidence. So on the one hand, we have a concept called age, and to define that as a construct, that would be very simple. We could basically look at the age of a person in years or in days or anything like that, right? So we could have a look at when a person is born and what is the year now, and that gives us the age of a person. So that's a single unidimensional construct. The concept of literature engagement might be a little bit more difficult to define as a construct. For example, we could say, look, we measure that as the number of books a person has read. That would be a very clear numerical variable ranging from 0 to infinity. But we would have a problem in measurement, such as that most people don't really recall how many books they have read. Also, there's not only books in this world, right? We could also count newspapers, we count magazines, we could count academic papers. So that could be multiple variables that are all good operationalizations, but they could be hard to get good measures on. We could think about other ways. So, for example, some people use a tool such as Goodreads.com, which is a web page, like a virtual bookshelf, that where it allows you to sort of put onto virtual bookshelves books that you have read, want to read, or are reading at present. And we could grab the data from there. Or, of course, we could go into a person's home and just count the number of books that are lying around. Another way of thinking about an operationalization of this literature engagement is that we ask people how much time they spend reading in a day or in a week or in a year or anything like that. And that would give us a different variable, such as, time spent reading. And people could say, look, I read a book a day, or I read half an hour a day on average. Ideally, perhaps what we would want to do is we would want to probably create a multidimensional construct. So we define several of these variables. So we grab whatever is on the virtual bookshelf on goodreads.com. We ask people how many books they think they have read over their lifetime. And we ask people how many minutes they spend reading every day on average. And then on the right-hand side, we have this notion of, intelligence. So here we could, again, do several things. So we could, for example, we could have people sit an IQ test. So that would give us a score for every person, including the lecturer, yeah, and presumably the age of a person and the number of books and the time spent reading, we would associate with a higher level of IQ attained. We could also do something like, because we said apparent intelligence, right? So we could actually ask a number of peers or other types of informants about how they rate the perceived intelligence of this person. So, for example, you could ask everyone in class to think about rating the intelligence of their lecturer on a scale from, God knows, 1 to 7 or 1 to 10 or anything like this. And again, we might think about doing more, multiple of these things. So having multiple variables, we have them sit an IQ test. We ask the peers about their parent intelligence, and then we have a very rich multidimensional operationalization of both concepts, both constructs, so to speak, and that relates us to, do a more precise test of our hypothesis that age and literature engagement relate to, improve intelligence. I hope this example clarifies something. This brings us to the end of this video lecture. Thanks for listening and watching.